Hey, we got a body over here.
Who is it?
There's ID right there.
Let's see here. It's Caden Shotwell.
Shot? What if she got shot? See any signs of wounds or any physical injuries?
No. Let's take a blood sample. Send it back to the lab.
Alright, so that's good. Let's get back to the ready room. Analyze it.
So what do you think the most reasonable cause of death is?
Well, there were no physical injury wounds, so we can assume that's something we can't see. Maybe some hemorrhaging, radiation. Can't imagine why that would be.
Yeah, most likely not self-inflicted. There were no large ledges, nothing to jump off of, and it was in the middle of the street.
What about poison?
That could work. The blood sample would definitely finalize that.
Yeah, we can have that sent to the lab. We can have them run 1 or 2 tests. We could have them run gas chromatography.
Alright.
Gas chromatography would work because it gives us retention time, the differentiating characteristic, and that gives us the time it takes for components of the substance to exit the capillary column, which then allows us to determine what makes up a mixture, and if it is a mixture, as each compound has a unique retention time.
Yeah, but are we sure it's a mixture though? It's not something we know about. It'll give us the intermolecular forces in relative terms, but we don't really know how anything to compare it to.
True. What other idea do you have?
We could do mass spectroscopy.
Mass spectroscopy would work, as we could find the molar mass of the substance and mass to charge ratio of it. That could provide us with the components of the substance that it can break into, the fragments, and this would be visible by the large peaks on the mass spec data. And it'll also give us the total molar mass, so we could use that to easily find the substance.
That's a good idea. Let's do that.
Alright, cool. I'll see you later.
All right.
What's up?
We got the mass spec data back from the lab.
How's it looking?
Like we thought, it's a pure substance, molar mass of 166 grams per mole.
It's not a lot to go off of.
It's not. I think we should have the lab run more tests. I think we can have them run TLC or FTIR.
TLC might work. It'd give us the strength of the IMFs with respect to the stationary and mobile phase, and we could use it to determine the relative strength of the IMFs of several solutions with a certain mobile phase, but
That's all relative. It doesn't do anything for us. We need concrete evidence now.
yeah, it's not quantifiable. It wouldn't give us identity.
No. What about FTIR?
FTIR, it'd tell us the bond's present, not present. That'd help.
That would help. It would tell us what's in the structure of it.
It'd give us information on the covalent bond present using EM radiation to see the vibrational transitions of the molecules. So, what do you think about that?
I think it's a good idea.
Alright, I think it'll work. Try it out.
All right.
Live action.
All right. We got the FTIR data back from the lab.
We find our mystery substance?
I don't think so. It tells us we have some carbon-hydrogen bonds, carbon-oxygen bonds, and some carbon-carbon bonds, but
Alright, we've
Not
got the
sure
mass
that's
spec
what's
right
going
here.
on.
So we've got mass spec, FTIR.
maybe use a
See
little
this?
more, honestly.
Yeah, we don't have any double bonds. There's no peak in between the 1500 2000 range. There's no OH bond. All single bonds, like you said.
I think we should run some more tests on it. I think we have 2 options. I think we can try running AS or NMR.
Those are final tests.
Yeah, one of those 2. Well, AS will give the absorbance of a certain spectrum of electromagnetic radiation of the substance, but you really think we need that?
Yeah, I'm not sure. It gives us the energy it absorbs, but it doesn't give us any info on the structure or the composition of the molecule.
That's right. What about NMR?
That'd probably work. We'd get differentiating characteristics such as signals, which give us the amount of different environments there are, or different environments that protons can belong to. It'd give us the chemical shift, which displays the specific chemical environments of the protons, and it also gives us this splitting as well, talking about the number of protons bonded to neighboring carbon atoms from the central atom. So, we should do it from there.
I think NMR is a good idea. I think we should go around that.
Yeah, we'd get a bunch of structure information in terms of groups of protons, and protons are hydrogen, so we get a lot more. We could combine mass spec, FTIR, and NMR to get the right compound.
Sounds your plan.
All right, see you later.
All right. All right, we got the results back for the final test.
What's it look like?
Take a look.
Alright, we've got 5 signals, 5 regions of electron density, bunch of splitting occurring. Looks good.
Yeah, I think with this data and our first 2 tests, I think we're good to finally figure out what this is.
Alright, any hints? Or any guesses?
I think it's 1-methoxyadamantane.
I do too.
Because if you just look at the mass spectrometry, the Fourier transform infrared spectroscopy, the NMR,
I've heard of this compound recently around.
yeah, it's a big thing.
Looks like it. Alright. Well, I guess the case is closed.
Yeah.
That's all, folks.